Hey guys, welcome to the studio. So this video is going to be pretty quick. At least I'm going to try to make it as quick as possible. I'm pretty much just going to go over all my specific slicer settings for 3D printing. That way, if you guys want to get into 3D printing and want to know all the different settings to put into your 3D printer, then you can use this as a guide, and then that way you can get off on the right foot and then not like make any 3D printing mistakes and waste any filament, because honestly there's a lot of different settings that you have to tweak just to make sure that you get your prints out. Not perfect, but pretty close to perfect. Anyway, we're going to jump right into it, and I'm going to start off with the standard settings that I use for your standard 0.4 millimeter nozzle. So right over here, just leave your layer height at 0.2, line width 0.4. Line width will always be your nozzle diameter. So since we're using a 0.4 millimeter nozzle, that'll be a 0.4 millimeter line width. And so later on in the later half of this video, I'm going to give you the settings that I use for a 0.6 nozzle. But anyway, yeah, you're gonna want to leave these settings in Cura all the same. Just don't touch it, don't touch any of the initial layer line width and whatnot. That you'd only change that if you're switching to a different size nozzle. Anyway, for walls, I like to typically leave it at about 1.2 millimeters thickness. If the piece really demands for a lot more strength, then I will sometimes up it to about 1.6. At a 0.4 millimeter nozzle, a 1.2 will create 3 lines for the wall, and that's pretty much a good balance between strength and conserving your material. Likewise, if you leave it at 1.2 and then you use a 0.6 millimeter nozzle, that will divide it pretty well and it'll leave it at 2 line count. You want to leave your other settings the same. I don't know if I changed this wall transitioning threshold angle. I kind of just leave it at 10 degrees. For wall ordering, I have it set to inside to outside. I also have optimized wall printing order. Z-seam alignment, I don't care too much about that. I either have it as user specified or sharpest corner. I typically do not use random because that'll leave a lot of blobs everywhere. But yeah, user specified or sharpest corner is the best. Hide seam is kind of a meh setting. Sometimes it'll affect it to improve quality, sometimes it won't. For top and bottom, I just have the top bottom thickness about 0.8 and with 3 top layers, and the bottom layer is about 3 lines as well. Everything I have set up is pretty standard with not too much changed. With the top and bottom line directions, I have it set to 90 and 0. Otherwise, most 3D printers will lay down their lines at a diagonal. I pretty much just have it set to right angles. That way the 3D printer can pretty much conserve its motors a bit longer. Skin overlap percentage, I have it set to 10%. I believe the stock settings are like 15. Everything else I believe I left the same as before. For infill percentage, this really depends on what you're 3D printing. If it's a really large chunk that is just really massive and really bulky, sometimes I'll just set it to 8 at cubic or cubic subdivision. Cubic subdivision is good for really conserving your material, and in order to keep it as lightweight as possible. 8% infill density with cubic sub is pretty much the minimum I will go for, because any less, and then the very top layer, where if you have a literally flat top layer, then anything less will cause some problems with the flatness. If it's a piece that requires a bit more strength, I usually up it to about 15%, either cubic sub or cubic. If it's something that really requires strength, I kind of just up it to 50% cubic. Somewhere between 20 to 50% cubic is good. You will almost never need to have it at 100% or anything close to 100% infill density. That's kind of just a waste of material. But anyway, yeah, that setting really depends on what you're printing. There are a lot of other infill patterns that you could test out. I just happen to like cubic and cubic sub, but go ahead and test some things out. Some of them are a little wonky, like lightning. Sometimes it really depends on how good your 3D printer is. And by the way, a lot of these settings I have set for a 3D printer that is a direct drive 3D printer. Direct drive is honestly just superior in my opinion. Info overlap percentage I have set to 30%. A lot of these settings, once again, are stock settings. You don't really need to mess with them too much. For materials, it once again depends on whatever you're printing. If you're printing with PLA, I have it usually set to 200 or 220. Really depends on how fast you're going. If you're going faster, you're going to want to up it to a little bit higher temperature. That way it's able to print and melt the material sufficiently as you're going super speed. If you're printing with PETG, I usually print it at about 245. Build plate temperature I have set to 50. Usually you'd have it set to like the standard of 60 degrees Celsius, but it kind of depends on the quality of your print bed as well. If your print bed is able to hold onto the material and prevent it from peeling off, then you're going to want to up the temperature a little bit. But just to save a bit of electricity, I kind of just have it set to 50 degrees Celsius. A lot of these other settings you kind of want to just leave stock. I do have the support flow at 90%. That's just to save a bit of material, and honestly, support, if it oozes out too much, then sometimes your nozzle can run into the support. So I just have it set a little bit lower, and I don't run into any difficulties with that. All right, moving on to speed. Now, this highly depends on what kind of 3D printer you have. For example, a lot of my small 3D printers, I have 3 Kingroon KP3S Pros, and those have a direct drive 3D printer, and they have linear rails. With linear rails, you're able to print a lot faster. You're not dealing with V-slots and those palm wheels that rub off really easily. With linear rails are really great because it's very low friction. You're able to print very quickly, and so with that, I'm able to print at about 120 millimeters per second. I do have the initial layer speed a little bit lower at about 60 millimeters per second. That's just to ensure that the first layer, I have it laying down really nicely, going just nice and slow, because the first layer is the most important. Same with the skirt and brim speed. I have it set fairly low at the standard 60 millimeters per second. Now, if I swap over to my Solval SV06, I have the print speed a little bit lower, still a bit faster than your standard at about 80 to 70 millimeters per second. That's because rather than linear rails, I have linear rods on those 3D printers, on that 3D printer, and so it can't quite keep up with the linear rails. But still, something like that is really good. If you have palm wheels or V-slots or anything like that, then just the standard 60 is good. You're really gonna have to tweak it depending on your own 3D printer. Anyway, if we move down and we go to the Z-hop speed, I do like to use Z-hop. I have the Z-hop speed set to very slow. About 4 millimeters per second is good. And the number of slower layers, I have it lowered to 2, I believe. That way, when it gets up to like very thin layers or very small layers, it can go ahead and just, not slow down to a snail's pace. You're going to want to enable acceleration control and enable travel acceleration. For the print acceleration, I believe the stock is about 1000 millimeters per second squared. Once again, this depends on your quality of 3D printer. If you have linear rails, then 500 is fine. It's just how fast it can be able to get up to its max speed. But, lower is fine. Lower is safer. It won't affect your printing speed too much. If you're running into layer shifts where one layer completely shifts off of it, you're going to want to adjust these settings here and adjust your acceleration settings to be lower. And you're going to want to also enable jerk control. This will also affect how often you encounter layer shifts. This is very important. You're going to want to lower your jerk as much as possible. Your jerk is essentially like your instantaneous acceleration. And if your motors slip or your belts slip or anything like that happens, then you're going to encounter a layer shift. And that's horrible. That completely ruins the print. And so you're going to want to lower to something like 2 millimeters per second. Even 1 would be great. But yeah. Anyway, those are your speed settings. There's a lot to change there, but it's pretty straightforward. For your travel, oftentimes I like to enable retraction. If I'm printing with PETG, I turn that off because PETG, oftentimes, it's very stringy. When you're printing it, it's more prone to curling, and then that curled corners or edges, it can oftentimes cause your nozzle to run into them and just completely ruin your print. I do have retract at layer change turned off, but if you're not printing PETG, I like to enable retraction. The retraction distance, I have it set pretty darn low. I'm able to get away with this because I have a direct drive 3D printers. So with this, I have it set to 2 millimeters. With a Bowden tube, I'd probably start off with 5 millimeters and then just see how the quality of your stringing is. If you can avoid getting too much stringing, then that's what you're going to want to do. With retraction speed, I have it set pretty low as well at about 5 millimeters per second. That's just to avoid, like, because it really depends on how brittle your filament is. Sometimes if it's very brittle and you're running your retraction too fast, it can sometimes cause a break, an internal break within the hot end itself, and that is just a whole headache to deal with. If it's also too fast and your filament is very soft, really pliable, sometimes sometimes the wheel that grips and bites into your filament, it grinds it away and causes it to just have like it grinds it away to the point where it can no longer grip it, it can no longer push it, and then that just completely ruins your print as well. So trying to find that middle ground, just going really nice and slow with it is really nice. On the same note, I also have the retraction minimum travel also fairly high. I have it set to 10 millimeters. That's a full centimeter, because oftentimes when you're printing something and there's a lot of retractions within a small space, you're gonna watch that 3D printer constantly retracting, ooze out a tiny bit of filament for this small space, retract again, ooze out a little bit after moving a little bit, and that opens you up to so many jams and so many clogs. That way, and for that reason, I have it set to a much higher value than what the stock settings are, at about 10 millimeters per second. If you end up with any like leftover oozing where it doesn't retract all that much and you are left with stringing, it's better to just sand that away and maybe heat gun that away versus having a whole failed print. I have the maximum retraction count at 20 as well. That's just to reduce the amount of retractions within a certain length of filament to avoid too much grinding on it. The rest of these settings I have kind of stock. Limit support retractions, yes. Retract before outer walls, yes. Z-hop when retracted, yes. For my Z-hop height, I have it set to about 0.6 millimeters. This will vary a little bit, really depends on the material you're working with. Now, if your 3D printer has its extruder be like really aggressive, for example, my giant Core XY 3D printer, it's a Trudon. Its extruder is so aggressive that I cannot use PLA with it. I don't know if it's like that particular extruder that they shipped out of the factory, but for some reason PLA, it will just grind to a halt, it'll start jamming up, so I have to only print PETG with that 3D printer. And with that 3D printer, since I'm printing in PETG, even then sometimes it has a problem with just shoving shit out of the nozzle. And so with that, oftentimes it'll grind things away, it'll smush the 3D printing material, the filament, to the point where I have like a jam on the inside of the extruder of the hot end itself, and that's a whole pain in the ass to deal with. And so in that case, sometimes I have the retraction be super low. For example, if I pull it up right here, I have the retraction set to 1 millimeter and the retraction speed even lower. And then I have the retraction minimum travel to like 50 millimeters. That's 5 centimeters before it even retracts. So it highly depends on your 3D printer that you have. But yeah, definitely play around with it. As long as you learn what settings affect what and are able to diagnose problems with your 3D printer, then you're able to tweak things for yourself. Cooling, you can leave it alone if you want. I have the fan speed lowered a little bit just to reduce noise. Fan speed, you know, it helps with 3D printing, but you don't have to have it at max all the time. For supports, oftentimes I just leave it at zigzag. Your 3D printer, most 3D printers are able to handle much higher support overhang angles than you give it credit for. I found that a 65-degree angle is pretty good for most applications. If you just look at your 3D model and you see that it requires a lower support overhang angle, then definitely lower it. Sometimes I'll just lower it to 50 if it's a 45 degree and I think it needs more surface contact to prevent the 3D print from breaking apart from the support material itself. Then I will lower it. That way it can have much more surface area to grasp and keep that print in place. And sometimes I even just lower it way lower. It really depends on what you're 3D printing. Oftentimes I have it touching build plate or everywhere. And then oftentimes I'll use some support blockers as well. That's an easy video to look up on your own time as well. I usually have the support density set to 8%. You can kind of up this to 10 to 15% if you really want higher quality surface on where the support touches. But 8% is like kind of the minimum if you really want to save material and let it not look awful. So yeah, there's a lot of settings here, so you can go ahead and slow down the video or pause and then just copy and paste them. But I will say that your support Z distance, I would have it set to about 0.4 millimeters. This is pretty much the distance between your support and your actual print itself. You're going to want to have it be at the perfect sweet spot. That way it can hold it in place and not not have too much of a gap where the bottom surface looks awful, but you also don't want it to be so close that it melts and fuses into your actual print itself, and then that makes like tearing it off just an awful experience. So I found that 0.4 millimeters is usually the nice sweet spot. As long as the rest of your settings are tuned very well, then that should be fine. So for support X and Y distance, I have it set to 1.4 millimeters. That's pretty much the distance between your support and your actual print material. That you also don't want it to be too close together for obvious reasons. I have Z overrides X and Y, and a whole lot of other settings that I honestly don't remember if I changed or not. So you can double check with your own settings to see if you can update it for yourself. Or if you want to experiment, go ahead and tweak them for yourself. I will say that having a high percentage of support interface density is very important. You can very easily just look it up yourself, but yeah. Once again, I have quite a few settings here. Minimum support interface area. I also have towers enabled with a lot of different settings, but yeah, a lot of different things to set up. But as long as you set them up beforehand, you're pretty much good. Now, build plate adhesion. I personally like to use a brim most of the time. I almost never use a raft, and I very rarely ever use a skirt. Sometimes I'll use none if there's plenty of surface area making contact with the bed. But yeah, oftentimes I use 3 millimeters worth of brim width. That's usually the standard. If you don't have very much surface contact, then you can definitely up the brim width. Once again, this is something you would likely tweak depending on what you're printing. Oftentimes I have brim only on the outside, but if you have internal holes, sometimes you'll want to turn that off as well. Don't mess with dual extrusion, that's a very specific thing. For mesh fixes, oftentimes the union overlapping volumes is already checked. If it is not checked, make sure that it is checked. That is so important. I wouldn't mess with special modes too much. It really depends on what you're trying to do. For experimental, this is very important for tolerances. I always use exclusive for slicing tolerances. You can look up what that means and how that affects your 3D print yourself, but pretty much that's like, that affects how your 3D printer decides to lay down material depending on the 3D model that you're using. And that highly affects tolerances. So exclusive is almost always what I use. As long as you have supports on, the enable conical support option will be available. I always turn it on just to save a bit more material. However, when you are turning it on and you are using it, I would recommend setting your angle to 30 degrees and have your minimum width be about 12 millimeters. That way you ensure that whatever conical support you're using, it doesn't just snap and break off. But that's a pretty good setting for saving a bit more material. A lot of these other settings I don't mess around with too much, but yeah, that was the experimental, and that's pretty much it. A lot of the other settings in Kira or in a lot of other slicing softwares you can mess around with. For example, using support blockers or manually putting in supports. But that's a little beyond the scope of this video. This video, I just wanted to show you guys a lot of the settings I have. However, that's pretty much for 0.4 millimeter nozzles. So I'm going to swap over to one of my 0.6 millimeter nozzle printers and show you guys the quality I use. So for this one, a lot of the settings you're going to use are going to remain the same. However, the layer height, I have it set to 0.32 millimeters. That's a pretty good in between your 0.2 and what you might expect of just raising it up even higher than that, but that's pretty good in between. Kira does a pretty good job of pretty much taking your layer heights into account with the actual flow that is necessary for a good print. So you don't have to mess with flow rate whatsoever if you are using a higher nozzle for your 3D printer. Once again, update your line width. That way you can let Kira know that you are using a larger nozzle size, and then pretty much leave the majority of other things the same. I would just recommend setting your wall thickness. You can leave it right there, and then Kira will automatically update the wall line count. A lot of the other settings you can get away with. For example, since you're using a thicker nozzle and laying down thicker lines, your infill density, you can leave it at 0.8, and then even with such a low infill, it will actually increase the strength of your 3D print. A lot of other things, for example, your material, if you were using a 0.4 and using a lower heat, you might want to up that heat a little bit more, because you are definitely pushing out a lot more material per second or per line distance or whatever. And so you're going to want to up the heat a little bit more. But pretty much a lot of your settings you're going to leave the same. You can definitely tweak it on your own free time, but that's pretty much it. But yeah, that's pretty much it for this video. I definitely wanted to get this video out there at some point. If you guys have any questions that are a little bit more specific, you can go ahead and ask me down in the comments below. Anyway, like, subscribe if you want to, and see ya!